Hello, everyone. I hope you're having a good day.
Welcome to another AI pattern recognition deep dive.
What if we told you that deep down, it all boils down to one thing AI has totally mastered: just seeing patterns?
That's really the core of it.
Welcome to the pattern universe, how AI sees, learns, and shapes our world. Another deep dive where we take your sources and, well, unpack the most interesting bits.
Yeah.
Today, we're peeling back the layers on AI pattern recognition and, what it means for everything from your morning coffee order to, like, global climate forecasts. Okay, let's dig in.
It's absolutely true. The universe, from the tiniest protein folding up to huge global market swings, it's just full of patterns.
Yeah.
And AI, basically through machine learning, has developed this really sophisticated grammar, you could say, for reading this pattern language.
A grammar. Interesting.
Yeah, and understanding this engine, this insight engine, that's really the first step if we want to harness its huge power responsibly.
So, our mission for you today is to decode how AI actually learns these patterns, how its digital brain is put together, and then what happens when AI starts evaluating, well, other AIs, us humans, and even the pulse of society itself. You should walk away understanding not just what AI does, but why this pattern mastery matters so much for where we're heading. So, okay, if AI sees patterns, how does it actually learn this patterned language? Does it just, I don't know, magically figure it out?
Not quite magic, but it learns through, let's say, three primary pedagogical frameworks or learning paradigms.
Yeah.
And each one defines a specific goal for the AI. Is it trying to validate knowledge we already have, discover completely new structures, or maybe optimize some kind of action?
So choosing the right one is crucial.
Absolutely. It's a strategic choice. It really determines the AI's core purpose.
Let's start with the one most people probably know, right? Supervised learning.
Yes, exactly. That's the most established, the most widely used. Think of it like a student who gets a big stack of practice problems with the answers already filled in.
Okay, like a study guide.
Pretty much. The AI gets a large labeled data set.
Yeah.
So every piece of data, maybe an image or some text, it's already tagged with the correct output, the right classification.
Gotcha.
And the AI's job is basically to learn the mapping function, the sort of mathematical rule that connects that input data to the correct output label.
So it can predict for new stuff it hasn't seen.
Precisely. So it can then accurately predict for new unseen data.
So it's learning from a clear instruction manual, essentially becoming a classifier.
Exactly right. A classifier is just an AI model trained to put data into categories we've already defined. The learning happens in two main stages.
Oh, okay.
First, there's training. You split the data. The model learns from the training set using algorithms like, well, support vector machines.
Okay, what do they do briefly?
They basically find the best line or boundary to separate different types of data points. Or you might use decision trees, which are kind of like flowcharts for making choices, or even random forests, which just combine lots of those decision trees to get, more robust predictions.
Makes sense.
Then, second stage, this trained model, this classifier, gets validated against a separate test set just to check how accurate it is on fresh data.
And that's how it spots spam or recognizes my face?
Exactly. Identifying spam, recognizing specific faces, classifying medical images. Is it malignant or benign? Or predicting dodgy financial transactions? Its main goal is prediction and validation. Learning and then applying rules it already knows.
What if you don't have all those answers? All that perfectly labeled data? I mean, that sounds like a ton of work to create in the first place.
You've hit on a really key challenge there. Creating labeled data is expensive and time-consuming. That's where unsupervised learning comes in.
Okay.
This is more like an explorer, maybe charting unknown territory without a map.
Interesting analogy.
The AI just gets a whole bunch of unlabeled data, and it challenges itself to find inherent patterns, groupings, structures, all on its own. It's not told what to look for.
So it's finding connections we might not even know exist without any hints.
Exactly that. Its job is to find meaningful regularities hidden in, maybe, massive, complex data sets. The main technique here is called clustering.
Clustering, like grouping similar things together.
Precisely. Algorithms group data points into clusters based on how similar they are. Like K-means clustering. It tries to make a specific number of groups where things in each group are close to a central point.
Okay.
And another big one is association rule mining. Famous example is market basket analysis.
The diapers and beer thing.
That's the one. Retailers using it to find out that, customers who buy diapers also tend to buy beer. It reveals these hidden buying habits.
Fascinating. So applications would be things like...
Well, customer segmentation is a big one in marketing,
Hmm.
grouping customers by buying habits. Or anomaly detection, spotting unusual network traffic that might be a cyber attack.
Right.
Its goal is pure discovery, finding new insights, generating new hypotheses just from the raw data itself.
And then there's a third type. This one sounds more about like action and strategy, not just identifying or classifying stuff.
That's reinforcement learning. It's actually modeled on behavioral psychology, how we learn.
Okay. How so?
You have an autonomous agent that's the AI, and it learns by doing things, taking actions within some dynamic environment. Could be a game, could be the real world.
I see.
And its goal is to maximize a cumulative reward it gets over time. It's basically learning through trial and error. It gets positive feedback for good actions, maybe negative for bad ones, but often the feedback isn't immediate.
So it's learning from consequences, like a kid learning not to touch a hot stove, maybe, though hopefully the AI's consequences aren't painful.
Ah, exactly. It's a great analogy. The real tricky part here is balancing exploration, trying out new random actions to see what happens, maybe you find a better reward, versus exploitation, just sticking with what it already knows works best to get rewards now.
Ah, the explore-exploit dilemma.
That's it. Over time, the agent learns an optimal policy, which is just its strategy for choosing actions that, on average, lead to the best long-term outcomes.
And this is the tech behind.
Well, game-playing AI, like DeepMind's AlphaGo mastering Go, that was a huge milestone. Also, robotics, learning to walk or navigate. Autonomous driving systems, learning how to handle traffic.
Makes sense.
Its fundamental goal is discovering the best strategy or sequence of actions to take.
So, okay, we've got these three ways AI learns. Supervised, unsupervised, reinforcement. They clearly approach learning differently. But for you listening, how do these, technical distinctions translate? Is it really all about the purpose behind it?
It absolutely is. For you, whether you're making policy or, say, business decisions, really getting this difference, are you trying to validate something, discover something totally new, or optimize a series of actions? That's crucial.
Because if you use the wrong one?
Exactly. If you try to use, say, supervised learning to find truly novel market segments,
Yeah.
well, it's just not designed for that. You'll end up with solutions that are inefficient or maybe just plain wrong.
Okay, so that's how AI learns what patterns are. But the next step, maybe even more fundamental, is how does it physically, perceive and process that information to actually see these patterns? This gets us into neural networks. Right?
That's exactly right.
Yeah.
The engine driving most modern AI pattern recognition is the artificial neural network. And yeah, it's inspired by the structure of the human brain.
How closely, though?
Loosely inspired, let's say. It's a computational model. You've got interconnected processing units, often called neurons, and they're arranged in layers. Just think of it like a series of filters, maybe, that refine information as it passes through.
Okay.
So you have an input layer. That's where the raw data comes in. Then you have one or more hidden layers. This is where the really complex processing happens, what people often mean by deep learning.
Right, the deep part.
Yeah. And finally, an output layer that gives you the result. And the crucial bit is that the connections between these neurons have weights. These are just numerical values, and they get adjusted during the learning process.
So the learning is actually changing these weight numbers.
Precisely. The final pattern, the knowledge the AI has learned, is essentially encoded in the final configuration of these millions, sometimes billions, of weights.
Okay, so how does that learning actually happen down at that level, adjusting all those weights?
It's actually a really elegant two-part cycle that repeats over and over. It's often based on an algorithm called gradient descent, which is like teaching the network to roll downhill to find the lowest point in an error landscape.
Okay, rolling downhill.
Yeah. First step is forward propagation. Data flows in the input, goes through the hidden layers to the output. At each neuron, it does a calculation, basically a weighted sum of its inputs, and then critically passes that result through something called a nonlinear activation function.
Nonlinear. Why is that important?
Hugely important. Common ones are ReLU, that's rectified linear unit, and it sort of acts like a switch, letting positive signals through, blocking negative ones, or sigmoid, which kind of squashes values into a range, like 0 to 1. Without this nonlinearity, the network could only learn really simple straight-line relationships.
So the nonlinearity lets it handle complex, messy, real-world patterns.
Exactly. Curves, interactions, all the complex stuff. Then comes the second part, backpropagation. The network's output is compared to the answer it should have gotten. The difference is the error or loss.
Right.
Then an algorithm works backward through the network, tweaking all those connection weights bit by bit in a way that reduces that error next time.
So it learns from its mistakes going backwards.
In essence, yes. This whole cycle, forward pass, calculate error, backward pass to adjust weights, repeats maybe thousands, even millions of times. It gradually finds the weight settings that best map the inputs to the desired outputs. It's like the AI is refining its understanding through tons of practice and self-correction.
And I guess these networks can be specialized, like different architectures for different kinds of patterns, images versus, say, language.
Absolutely.
Yeah.
For computer vision, for images and video, convolutional neural networks, or CNNs, are the state of the art.
CNNs. Okay. What's special about them?
Their layers are designed to automatically learn features in a hierarchy. Early layers might detect simple things like edges or colors. Deeper layers combine those to recognize textures, then shapes, and eventually whole objects, faces, cars, cats, whatever.
So it builds up the understanding layer by layer.
Exactly. And it learns what features are important directly from the data, which is super powerful.
So this is the tech behind stuff we see all the time, like facial recognition on our phones.
Precisely that.
Yep.
Facial recognition, self-driving cars, identifying pedestrians and other vehicles, medical image analysis, spotting tumors. That's largely CNNs at work. It's how AI builds complex ideas like cat from simpler patterns like fur texture and pointy ears.
Okay. And what about things that happen over time, where the sequence matters, like a conversation or maybe a stock market trend?
Good question. For that, you typically use recurrent neural networks, or RNNs. They're designed specifically for sequential data.
Recurrent. How do they work?
They have these feedback loops. This gives them a sort of memory. It means when they process the current piece of data in a sequence, they can also consider the information from the previous pieces.
Ah, like remembering the beginning of a sentence helps you understand the end.
Exactly that kind of idea. Context is key. This makes RNNs essential for things like machine translation, speech recognition, or at forecasting financial markets anywhere where what happened before influences what's happening now.
Incredible. But this layered approach, this complex learning, it also leads to that thing people talk about, right? The black box problem.
You've absolutely hit on a critical challenge. The very complexity that makes these deep learning models so powerful. The intricate layers, the millions or billions of parameters, often makes their decision-making process completely opaque to us humans. That's the black box.
But okay, if the AI is accurate, why is that a problem for us? I mean, if it works, does it really matter if we understand how it works?
Oh, it matters deeply because it creates significant risks. Without understanding the how, hidden biases learned from the data can creep in and get amplified.
Right.
Holding someone or something accountable when the AI makes a mistake becomes really difficult. And fundamentally, human trust just erodes if we can't get some explanation. Plus, it's hard to debug problems or even ensure these systems meet legal or regulatory standards if you can't peek inside.
Can you give us a concrete example where an AI might be accurate, but for totally the wrong, maybe dangerous reason?
Sure. There's this famous cautionary tale called the Clever Hans effect, named after a horse, apparently.
A horse, okay.
Yeah, a horse that seemed like it could do math, but was actually just reading subtle cues from its trainer. An AI version might be, say, a model trained to diagnose COVID-19 from chest x-rays. It might achieve really high accuracy in testing, but maybe it's not looking at the lungs at all. Maybe it learned to recognize the font used by the hospital that had more severe cases in the training data.
Whoa, so it latched onto a completely irrelevant pattern.
Exactly, a spurious correlation. And in the real world, deployed in a different hospital with a different font, it would fail catastrophically. Only by understanding why the model is making its decisions can we catch these dangerous flaws.
Right. So how do we open that black box? How do we make it more transparent?
That's the whole goal of a field called explainable AI, or XAI, trying to turn these black boxes into more like glass boxes.
Glass boxes. I like that.
Yeah. There are sort of two main strategies. One is intrinsic interpretability. That means designing the AI model to be simple and transparent right from the start, though sometimes these simpler models aren't quite as powerful predictively.
Okay. And the other way?
More commonly, we use post hoc explainability. That means you take your complex, already trained black box model and you apply special techniques afterwards to probe its behavior and try to figure out its reasoning.
Can you give us a flavor of how those post hoc techniques actually work for someone listening who's curious?
Sure. One really popular one is called LIME. That stands for Local Interpretable Model Agnostic Explanations.
LIME.
What LIME does is to explain one specific prediction, it creates lots of slightly tweaked versions of that input data point. Then it trains a much simpler local model just to mimic how the big black box behaves right around that specific point.
So it builds a simple map for just one spot.
Kind of, yeah. So for example, Lime could highlight for you which specific words in a movie review were most influential in the black box, deciding it was a positive sentiment review.
Ah, okay, that's really useful for understanding single decisions.
It is. Then there's another approach called S-shape. That's Shapley additive explanations. It's a bit more grounded in game theory, actually. SHE assigns a precise value, a SHA value to each feature or input, showing exactly how much that feature contributed to pushing the final prediction higher or lower compared to the average prediction.
So like for a loan application that got denied.
Exactly. An S-shaped explanation could tell you precisely how much factors like your income, your credit history, your debt level, each contributed towards that rejection decision.
That's powerful. And there are others too.
Oh, yeah. Things like counterfactual explanations are interesting. They tell you the minimum change needed to flip the decision. Like, your loan would have been approved if your annual income was just $5,000 higher. Very actionable for the user.
This feels like it's way more than just a technical fix. It sounds like it's really about reshaping our whole relationship with AI, building actual trust.
It absolutely is. XAI is a fundamental shift. It moves us away from just blindly trusting an output towards a more critical partnership. It allows us, the humans, to evaluate the evaluator.
Evaluate the evaluator. I like that phrase.
And that's totally essential if we want to deploy AI safely and ethically, especially in high-stakes areas like healthcare, finance, justice.
Okay, so that's how AI learns and how we're trying to understand its learning. But this idea of evaluation, it goes way beyond just checking the AI's own homework, right? AI is increasingly being used to assess, well, pretty much everything. Other AIs, human performance, even the health of society. It's adding this whole new layer of algorithmic judgment.
That's a great way to put it. This whole concept is sometimes called evaluation AI. And one of its most immediate and really critical uses is in quality control for other AI systems.
Ah, AI checking AI.
Exactly. Especially for these complex generative models, like the large language models, the LLMs, that create text or images. Their output isn't fixed. It's creative fluid.
Right, you can't just check if it gave the right answer easily.
Precisely. Traditional testing methods often fall short. So a cutting-edge technique is using a very capable judge LLM, maybe something like GPT-4, to evaluate the output of a candidate LLM.
Using AI to judge AI. How does that work?
It's often called LM as a judge. You give the judge LLM specific criteria written in natural language, like a rubric. Things like fluency, is it grammatically correct, easy to read? Groundedness, is it factually consistent, is it hallucinating? Answer relevancy, does it actually answer the question? And crucially, safety, does it avoid harmful or biased content?
So this is how the AI tools we interact with actually get better and safer over time.
It's a huge part of it, yes. Continuous evaluation and refinement.
And what about using evaluation AI to find and fix bias within AI systems?
That's paramount. AI models can unfortunately learn and even amplify societal biases hidden in their training data. So an AI auditor system can perform systematic bias and fairness audits.
How would it do that?
It analyzes statistical patterns. Does the model perform differently for different demographic groups? For example, you could feed a hiring recommendation model identical resumes, just changing maybe a name typically associated with a certain gender or race, and see if the recommendations change systematically.
Wow. Or testing facial recognition across different skin tones.
Exactly. Measuring error rates across groups to identify and then hopefully mitigate those harmful biases.
It's even being used to uphold academic integrity.
Yeah, there's a really interesting case out of the University of Colorado Boulder. They used AI to sniff out predatory scientific journals.
Predatory journals? You mean ones that just take money without real peer review?
Exactly those. The AI analyzed journal websites, looking for patterns, maybe fake editorial boards listed, lots of grammatical errors, suspiciously high publication volumes, and it flagged over 1,400 potentially predatory journals.
So AI acting as a guardian for human institutions, that's fascinating.
It shows that potential, yeah.
Okay, that's AI evaluating other AIs and institutions, but it's also evaluating us, humans. How's that happening?
Well, in the corporate world, for instance, AI is being used to analyze huge amounts of data emails, Slack messages, project management software to assess employee performance and productivity.
Really? Is the idea to be more objective than a human manager?
That's often the goal, yeah. To try and overcome the biases that can creep into traditional performance reviews and provide a more continuous, maybe data-driven picture of someone's contributions.
Can you give an example?
Sure. It might recognize a software developer who consistently starts using new, more efficient programming tools flag that as a positive contribution, maybe even offer some real-time feedback or suggestions.
And in customer service, too, I imagine. Evaluating interactions.
Definitely. AI analyzes call transcripts, chat logs, audio,
Yeah.
looking for patterns linked to successful outcomes, maybe empathetic language used by the agent or how efficiently they solve the problem. Some advanced systems even do real-time sentiment analysis or suggest better ways for the agent to communicate during the call.
Aiming for better customer relationships. What about education, though, with generative AI making it so easy for students to just generate essays? That seems like a massive evaluation challenge.
Oh, it's created an unprecedented headache, a real cat and mouse game, as you say.
Because the old plagiarism detectors don't work well.
Exactly.
Yeah.
Traditional plagiarism tools are largely ineffective against unique AI-generated text. And frustratingly, the tools designed to detect AI writing are often pretty unreliable themselves. They have false positives, false negatives.
So what's the result?
It's led to a really significant shift, actually. Many universities and colleges are finding they have to revert to analog methods of assessment. Things like in-class, handwritten exams, the old blue books, and oral exams, face-to-face defenses.
Wow, a return to analog. That's a huge reversal of the push towards digital education.
It is. It shows a situation where AI has actually made evaluating authentic human work more difficult, not less.
This all sounds like, I don't know, a powerful new kind of algorithmic authority that could genuinely reshape our cultures, our workplaces, our schools.
It certainly could, and we need to be really mindful here. The criteria an AI uses for evaluation, they are not neutral. They're encoded with specific values, whether we realize it or not.
How?
Well, if an AI system is programmed primarily to reward, say, speed of completing tasks, then employees, students will naturally optimize for speed, maybe at the expense of thoughtfulness or creativity or quality.
Ah, the danger of teaching to the algorithm.
Precisely. Where people tailor their work not towards genuine learning or making a meaningful contribution, but simply towards getting a high score from the AI system. The big challenge is designing evaluation AI that's sophisticated enough to recognize and reward a diverse and holistic range of valuable human skills and contributions.
And when AI starts evaluating really large-scale systems, like, say, political sentiment on social media,
Yeah,
it's not just a passive observer anymore, is it?
exactly right. It becomes part of the system itself. Think about it. AI analyzes sentiment trends on Twitter or Facebook. Political campaigns then grab those AI-generated insights,
Okay.
and they use them to craft highly targeted ads and messages, which they then inject back into that same social media ecosystem.
Ah, so they're trying to change the very sentiment the AI was measuring.
Precisely. The AI is no longer just observing the system. It's part of this feedback loop that is actively shaping the system.
That feedback loop makes the AI an active player, changing the landscape it's supposed to be measuring. That feels profound.
It really is. Understanding and learning how to manage these kinds of recursive feedback loops, where the AI's analysis influences the reality it analyzes, that's one of the most critical and, frankly, difficult challenges we face with AI today.
Because they could spin out of control.
They could absolutely accelerate things like hyperpolarized echo chambers. But managed wisely, maybe they could also help create more responsive governance, systems that adapt better to public need. It really raises the question, how do we ensure AI shapes society for the better?
It feels like these patterns AI is learning, they're just everywhere, touching almost every part of our lives. Maybe we should zoom out a bit and look at how this pattern recognition is being used across some big foundational areas.
Yeah, absolutely, because this really is a general-purpose technology. It's transforming whole sectors. Think about how it impacts just our own human behavior day to day.
Okay, like what?
Well, consumer behavior and hyper-personalization. Starbucks has their Deep Brew AI. It looks at your past orders, your location, maybe even the weather.
To suggest my usual iced coffee on a hot day.
Exactly. Or Amazon's recommendation engine. It's tracking these tiny micro-patterns, what you click on, how long you hover over an image, to tailor your shopping experience just for you.
And sometimes it gets a bit creative.
Yeah. Remember that Nutella Unica campaign? They used generative AI to create 7 million completely unique labels for their jars.
Wow, 7 million.
Yeah, it turned a standard mass-market product into something collectible, tapping into that human desire for individuality. Pretty clever pattern application.
From personalized Nutella jars to the actual blueprint of life itself. I mean, biology and medicine seem like huge areas for this.
Oh, profoundly impactful. AI is analyzing vast amounts of genomic data alongside clinical information. This helps create personalized risk scores for complex diseases like cancer, much better than we could before.
And image analysis, too.
Big time.
Yeah.
We mentioned CNNs earlier. They analyze medical images, X-rays, CT scans, MRIs to detect things like early-stage tumors, often with accuracy that matches or even surpasses experienced human radiologists.
Amazing.
And probably the landmark achievement recently was AlphaFold.
Right, predicting protein structures.
Exactly. Predicting the complex three-dimensional structure of proteins just from their amino acid sequence. That was a massive biology problem. And AlphaFold cracked it with incredible accuracy.
Yeah.
It just unlocks huge possibilities for understanding diseases and designing completely new drugs.
Okay, what about the really big systems that run our world, like economies or the planet itself?
In economics, AI is analyzing enormous data sets, not just numbers, but also unstructured stuff like news articles, social media trends, even satellite images of, say, shipping activity.
To get better forecasts.
For much more accurate and timely forecasts of things like GDP growth or inflation. And of course, it powers algorithmic trading systems in finance, detecting tiny patterns and executing trades at speeds humans just can't match.
In fighting fraud.
Oh yeah, machine learning is absolutely central to modern financial security now. Companies like JP Morgan, PayPal, they use it constantly to detect transaction anomalies, and they've significantly reduced fraud losses as a result.
And for climate change, that's maybe the biggest pattern challenge of all.
It's a huge area of focus. AI is used to create emulators for those incredibly complex global climate models. These AI emulators can produce climate projections or long-range weather forecasts much, much faster, often with comparable accuracy to the massive physics simulations.
So speeding up the science.
Massively. Plus, AI analyzes satellite imagery to track things like deforestation or illegal logging in near real time. And it's improving natural disaster prediction, floods, hurricanes, which is vital for giving people early warnings.
It really sounds like AI is helping us shift from just reacting after something happens to becoming, I don't know, pre-responders by seeing the patterns beforehand.
That's a fantastic way to put it. Pre-responders. By detecting those subtle precursor patterns, whether it's in financial markets, disease outbreaks, or climate systems, AI gives policymakers, businesses, individuals the chance to intervene proactively, not just clean up afterwards. It's a huge potential shift.
So far, we've mostly talked about AI recognizing and evaluating patterns that already exist. But now, increasingly, AI is becoming a creator itself. It's generating entirely new patterns, new content.
Exactly. That's what some people call the generative mandate. These systems, like the LLMs and image generators, they don't just recognize cats in photos. They use their learned understanding of catness to generate brand new synthetic images of cats that never existed.
Like the AI creating those unique Nutella labels we talked about.
Precisely. Or large language models, drafting surprisingly coherent articles. Or diffusion models, creating these incredibly realistic, sometimes beautiful, sometimes bizarre images or even video just from a text prompt.
It feels like it's democratizing creativity in a way.
It certainly lowers the barrier to entry for many creative skills. But it's not just art and text. In science and commerce, generative models are being used to design completely novel molecules and proteins for drug discovery, things evolution never came up with.
Wow.
In finance, people are exploring AI, creating personalized financial advisor bots, maybe helping bridge the advice gap for people who can't afford a human advisor.
And what about the future of work? Everyone worries about automation.
Well, yes, AI will automate many tasks, that's undeniable. But it's also clearly creating entirely new roles. Things like AI trainers, the people who fine-tune these models, explainability consultants, the people who help us understand the why, AI ethicists, even human AI team managers.
So it's less about us competing against AI.
And much more about figuring out how to effectively collaborate with AI, leveraging its strengths while we provide the judgment, the context, the ethics.
But, okay, with this immense power to observe, to evaluate, and now to create, there've got to be some profound ethical questions, some challenges we absolutely need to tackle. This brings up a really important question.
Oh, absolutely. The power of AI pattern recognition brings with it equally significant challenges. Algorithmic bias and fairness is probably the most immediate and pressing one.
Because it learns from our messy, biased world.
Exactly. If the data AI learns from reflects existing societal biases, gender bias, racial bias, whatever the AI, will inevitably learn those biases. And worse, it can perpetuate and even amplify them in its decisions, leading to discriminatory outcomes in hiring, loan applications, even criminal justice.
Like the example of the hiring model trained on historical data biased against women.
Precisely. Even if there's no explicit instruction to be biased, if the pattern is in the data, The AI will likely find it and use it.
So the patterns it's fed can bake in human biases, sometimes without us even realizing it. What about data privacy? That seems like another big one.
Huge. Because AI's effectiveness often relies on having massive amounts of data to learn from. This creates real risks. AI can sometimes infer surprisingly sensitive information, health conditions, political views, even from data points that seem innocuous on their own, just by combining patterns.
And the surveillance aspect.
Yeah, combine powerful AI, particularly facial recognition, with the ubiquitous cameras we already have.
Well, you've got the technical infrastructure for widespread surveillance. That carries a real risk of a chilling effect on free speech and often disproportionately impacts already marginalized communities.
And if these powerful, maybe black box AIs cause harm, a self-driving car accident, a medical misdiagnosis, who's actually accountable? Who's responsible? That is the knotty challenge of accountability and transparency. Determining liability is incredibly complex when you can't clearly see why the AI made the decision it did. We desperately need clear legal frameworks, regulations, and probably mandated levels of explainability, especially for high-risk applications.
So wrapping this up, what's the ultimate takeaway from this whole deep dive into AI's patterned universe? What should we leave people thinking about?
I think the core takeaway is that AI is fundamentally a technology of dual potential. It holds immense power to help solve some of humanity's biggest problems: disease, climate change, scientific discovery. But it also poses profound challenges to our ethical norms, our privacy, our autonomy.
Two sides of the same coin.
Exactly. The same pattern recognition that can predict disease outbreaks could also amplify harmful biases. The same tech that monitors deforestation from space could enable mass surveillance on the ground. The crucial point is that the future trajectory is not predetermined. It will be shaped by the choices we make today about how we develop and deploy this technology.
And our role in shaping that future. So what does this all mean for you, the listener, sitting there right now?
Well, tackling the really grand societal challenges of this century, climate, health, inequality, it's almost certainly going to require human-AI cooperation. We can't do it alone anymore. The scale is too vast. The system's too complex.
So AI brings the scale and speed.
AI provides the scale, the speed, the ability to manage complexity, to find those subtle patterns in overwhelming data. But humans must provide the crucial elements: the ethical compass, the contextual understanding that AI often lacks, the ultimate sense of purpose. AI identifies the patterns, but we have to decide which patterns lead to a future we actually want to live in.
This deep dive really shows, I think, that AI isn't just another tool in the box. It's rapidly becoming a partner, sometimes an evaluator, even a co-creator in our world. It's an incredibly powerful force, yes, but one that absolutely needs our human guidance, our values, our ethical compass to make sure it truly serves all of us.
Couldn't agree more. Understanding these foundational mechanisms, how it learns, how it sees, how it evaluates, how it creates, and understanding its vast applications and its profound implications. That's really crucial knowledge for everyone now, not just tech experts. The choices we're making today will define this partnership and, in many ways, define the future of humanity alongside AI.
Okay, a final provocative thought for you to maybe mull over after this deep dive. If AI gets really good at predicting everything from disease outbreaks to climate tipping points, maybe even to individual human behavior, how does that change our very ideas about free will, about personal responsibility, in a world where so many patterns are suddenly laid bare for us to see?
Thank you for tuning in with us.
Something to think about it for all of us.